Alright, you have made it to the last video in this lesson. We're going to step away from the polynomials for just a minute, and we are going to take a look at something called the greatest common factor. This is something you should have seen in middle school. If you remember, it is abbreviated by the letters GCF. So anytime we're talking about finding the GCF, we're looking for the greatest common factor. And to think about what a greatest common factor is, we kind of have to first talk about what a factor is. If you remember, a factor is anything that is being multiplied by something else. We are going to have 3 steps to finding the GCF. The first is going to be finding the prime factorization of each number. The way you've probably seen this done in the past, and how we're really going to do it moving forward here as well, is by making a factor tree. And that's what we have over on the right here with step number 1. We had 36 and 54. We broke it down into some numbers that multiply to give us that, and we kept breaking it down until we had a set of prime numbers. Remember, prime numbers are numbers that the only things you can multiply to get that number are 1 and itself. And then after we find the prime factorization, we're going to look for the factors that are present in each number. So it has to be in each of the 2 different sides. So notice we put a line down the middle to divide the one with the 36 and the one with the 35. What we're looking for now is the ones that are shared. So if we looked at these, they both had a 2 and a 2. So that's where we got that shared 2. They both had a 3 and a 3. So that's where we got that 3. And then each of them also had one additional 3, which is where we got this 3 here. So when we look back at the other factors, this one still had another 2, but since we didn't have another 2 over here to match up with it, we couldn't count that as a shared factor. Same with the 3 on the side with the 54. So then the last step is, once we have found those shared factors, we're going to multiply the shared factors together. You'll also see those called common factors. So we had a shared 2, 3, and 3. So when we multiply 2 times 3 times 3, that's going to give us 18. So 18 would be the greatest common factor for the 2 numbers 36 and 54. Let's go ahead and jump into our examples. We're going to look at example 1, where we are asked to find the GCF of 12v squared and 18v. Now you'll notice in this one we do have some variables thrown in. So the first thing I would do when you have ones that have variables in it is to start your factor tree off by splitting up the coefficient and the variable. So I'm going to split this into a 12 and a v squared, because 12 times v squared is going to give me that 12v squared that I started with. We'll start with the easy one. The 2 things that you can multiply together to get v squared are v and v. And then we want to break down the 12. So there are multiple ways that you can go about this, because 12 does have multiple factors. You could put 2 and 6, or you could put 3 and 4. Either one will work. You'll still get to the same answer either way. I try to use the bigger and closer together numbers when possible, so I'm going to use 3 and 4. Now, notice that 3 is now prime. We can't break it down any further. The only things that we can break it down to is 1 and 3, but that's not going to help us out at all. My 4, however, can be broken down to 2 times 2. So since both of those are prime now, I'm going to circle those. And we also had the v and the v. So what my factorization of the 12v squared was 3 times 2 times 2 times v times v. That was each of these circled numbers that did not break down any further. And I would recommend that you circle those as you go through. That way you don't leave any behind. We're going to break apart the 18v now. So we're going to do 18 and we're going to do v. Now when we only have one v, we can't break that down any further, so I'm going to go ahead and circle that one. For 18, we could break that down a couple ways as well. We could do 2 times 9, or we could do 3 times 6. I'm going to go ahead and do 3 times 6. Now 3 is prime, so I'm going to circle that. It doesn't break down any further. But 6 does. It breaks down into a 2 and a 3. And each of those 2 numbers are prime. So now I'm going to take those numbers I circled over here and write it down over here. I had a 2 times 3 times 3 times v. So now I have my prime factorization. Those are the numbers that breaks down to. So I'm going to be looking for the ones that are in both sets, in both the blue set from the 12v squared and in the red set from the 18v. So the first thing I notice is I do have a 2 and a 2 in each of these. I also have a 3 and a 3 in each of these. Now the top one has an additional 2, but I don't have another 2 in the bottom, so I can't highlight that. But I do have one more thing that's the same, and that's going to be the V and the V. Now, I looked at the things that are not highlighted. I looked to make sure there wasn't anything else matching. We have a 2 and a V up here. We don't have another 2 and a V down here. We have a 3 in the bottom set, but we don't have another 3 in the top set, so that's all we have. So I'm going to multiply out the ones that were shared. I had a 2, a 3, and a V. And when I multiply together, that's going to give me 6V. So what this greatest common factor is going to represent is that is the biggest number that will go into both of these terms without giving us a fraction or a decimal. And a good way to check yourself on these problems is to actually go ahead and divide each of those by what we got as our greatest common factor to make sure there's nothing else that goes into those. So for example, when I divide 12V squared by 6V, if I do 12 divided by 6, that's going to give me a 2. And if I do V squared divided by V, I subtract the exponent, so that's just going to give me V. So I would have 2V if I divide by 6V. If I do the same thing to the 18V and divide that by 6V, that's going to give me a 3. And my V's are going to cancel out. So I would have 2V and 3. Now if there's anything that would still go into both of those, I would know that I have a common factor but not the greatest common factor. But in this problem, I can see that there's nothing that's going to go into a 2V and a 3 that's going to be the same. So my 6V over here that we came up with is going to be our greatest common factor. All right, one more example. Adding in an extra term on this one, we're going to follow the same process. We're just going to do it 3 times instead of 2 times. So I'm going to break apart the 2x squared to be a 2 and an x squared. Now, 2 is already prime, so I can't break that number down anymore. But x squared can break down into x and x. So I have my factors 2 times x times x. Those are my numbers that don't break down any further here. I didn't do a good job of this in the first problem. I kind of wrote that first set out of order. But it's going to make this easier if you write these going from the smallest number to the biggest number and then your variables. So now let's break down the 6x. I'm going to put the x over here to kind of save room, and I'm going to put the 6 over here. I know x won't break down any further, but I know that 6 breaks down to be 2 and 3. Now 2 and 3 are both prime, so I'm not going to be able to break those down any further. So I have 2 times 3 times x. And finally, I have my 8. No variables on this one, so I can go straight into the numbers. I'm going to go with 2 times 4. 2 is prime, so I'm going to circle it. And then 4 breaks down to be 2 and 2. So on this one, I just have a bunch of 2's. 2 times 2 times 2. And I want to look to see if there's anything in common. Now they all have a 2, so that's going to work. Now the problem with the x's is I have an x in the first set, and I have an x in the second set, but there is no x in the third set, so I can't use any x's in my common factor. That's all I have left in the top one is 2 more x's, and they don't match up with anything. My red set, the 3 is the only one that has the 3 in that set. There's no 3 in the top set or the bottom set. And in the bottom set, I just have 2 2's, which I don't have in the first or second. So on this one, all I can put for my greatest common factor is just 2, because that is the only one that would go into all 3 of those. And like I checked on the last one, if I divided 2x squared divided by 2, that's just going to give me x squared. If I divided 6x by 2, that's going to give me 3x. And if I did 8 divided by 2, that's going to give me 4. So we look at those 3 that we're left with, nothing will go into each of those. So I do have my greatest common factor, with that being 2. Alright, I know there are a lot of videos in this lesson. Go ahead and do these couple U-Try problems that we have for you guys. Check your answers, and then go ahead and get jump started on the practice. If you have any questions as you're working on the practice, please let your teacher know. We'll be glad to help you out. Alright, see you guys in the next lesson.